Everyone, welcome back, and today let's solve Leetcode problem 3423 titled Maximum Difference Between Adjacent Elements in a Circular Array. So we're given a circular array nums and we need to find the maximum absolute difference between all the adjacent elements, right? And in a circular array we have to note that the first and last elements are also considered to be adjacent, hence that circular property or tag, if you will. So in example 1, we have our input array nums to be 1, 2, 4, and our output to be 3, because that is the maximum difference between any two adjacent elements, also including the first and last element as well, right? If we were to just iterate over this input array nums and find all the adjacent elements, we go from 2 and 1, then we go 4 and 2, then we look at this 1 and 4 and just maximize the difference between all of those different pairs of adjacent elements across the iteration of our input array nums, right? And since the maximum is 3, that is what we're going to return. Basically, it's just the maximum difference that we find across all the I plus 1 and ith elements in the input array nums, right? That are basically just adjacent. In example 2, again, same exact logic. We first get the difference between the first and last number, but because we can't really iterate over that to check. In this case, the difference would be 0, because -5 and -5 are quite literally the same thing. And then we just iterate over the regular input array num by itself. We maximize the difference, and we maximize the difference between the overall difference across the entire input array and the first and last value, and whatever that is, that's our output, which is in this case 5, because that's the difference between -5 and -10. So for the constraints here, we see that the length of the input array nums is actually rather small, between 2 and 100, and any value in the input array nums is going to be between -100 and 100, which leads us to the main key observation to really make, which really is that this really is just a straightforward single iteration problem, where we iterate over the entire input array nums and maximize the difference between every element and the I minus 1th element in the input array nums. You can also do the I plus 1th element, it didn't really matter. Just need to maximize the difference between all the adjacent elements in the input array nums. And then finally, just handle the case of the first and last elements difference and just maximize the difference between those two values, and you have your output. So let's go ahead and get into the code here. And what I'm going to do is really just, again, initialize my result, or I'll call it max difference. Initially going to be 0. Iterate over the input array num, so for I in the range of the length of our input array nums. In this case, I'm going to start from index 1, because I'm going to compare every element nums at I to its adjacent element, in this case, nums at I minus 1. Right? That's the difference between the current two adjacent elements, and that's going to be our current difference. And we're going to set, or rather update, our maximum difference to be the maximum of either itself, if the maximum difference we've seen so far is greater than the difference of the current two elements, or the difference between the current two elements nums at index I and at index I minus 1, right? That's the current difference that we're maximizing, the max difference, right? It's going to be the maximum of either itself or the difference between the current two elements. Now, the next case that we have to handle is the first and last element. So I'm going to call it first and last, and we then have to calculate the difference between that, because there was a chance that that could be our maximum difference value or output, right? And really, it's just going to be the difference between the two values at index 0 and index -1 in Python, which is the last index, right? So it's going to be nums at 0 minus nums at -1, right? Basically, the difference between the first element, or the 0th element technically, and the last element. Now, there's one kind of key thing that we're missing here, and that is that we can't have negative values in our outputs, right? Because if we're currently at, per se, imagine we had a 2 here, and this was a 3. Imagine this 1 was a 3. The difference between 2 and 3 would be 2 minus 3, or -1. Now, the difference between them isn't negative, right? The difference between them is still positive. It's just that the total differing value between the two values is going to be 1, right? Because we always have to take the absolute values of the difference to get their true differences, and so that's why we always have to put in an absolute value here when we calculate our differences. Because whenever nums at index 0, or rather, I should say, whenever the value that we're subtracting from the current value, whenever it's bigger, although we're going to have a negative value as a result, they still have a positive difference, and so we have to take the absolute value of that actual difference, right? And that is actually going to be it for the code here. At the end of the day, all we have to do is just return the maximum of either the first and last elements difference, or just the overall difference or max difference across all the other elements in the input array nums, right? So on this I made in the syntax 0, 0, there should be accepted, and there should be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. So again, on a high level, how are we really solving this problem? Effectively, we just iterate over every single pair of elements in the input array nums. We get the maximum difference, and we get the difference between the first and last element, and just output the maximum difference between those two different cases. So for the runtime complexity here, quite straightforward. It's just going to be linear, big O of n, because really we just have one overall main pass or iteration or loop over the input array nums. Right, and so it is going to be linear for the runtime complexity, and for the memory or space complexity, it's actually constant or big O of 1, because we're not actually using any auxiliary memory or any extra data structure to solve this problem. Really just a few extra integer variables like max, difference, and first and last, hence a big O of 1 or a constant time memory or space complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.